All right, so if we have 5 liters of a gas at 110 kilopascals and the pressure is changed to 650 millimeters of mercury, what is the new volume of the gas? So I'm dealing with volume and I'm dealing with pressure. There's no mention of number of moles or mass of the gas, and there's no mention of temperature. So we assume that those two things, T and N, are constant. If T and N are constant, and we're just dealing with pressure and volume, this is Boyle's law, an example of Boyle's law. Boyle's law is P1V1 equals P2V2. So make a list of our variables. P1 is 110 kilopascals. V1, that's our initial volume. We're starting at 5 liters. P2 is 650 millimeters of mercury, and V2 is what we are solving for. So the new volume, that's our final volume, is V2. So the issue here, I can rearrange my equation if I'm trying to isolate V2. So I want to isolate V2. That means I have to get rid of the P2 and move it to the other side of the equation. When we're isolating variables, we always do the opposite operation. So right now, V2 is being multiplied by P2. So the opposite of multiplication is division. If we divide by P2, we can cancel this out. That means I also have to divide by P2 on this side. So when we rearrange it, V2 equals P1 V1 over P2. Now the trouble is I can sub these variables into the equation, but they have to be consistent units. We always want to have our pressure in kilopascals and our volume in liters. So my volume and my initial pressure are fine, but my final pressure, P2, is in millimeters of mercury. So I can't substitute this into the formula as it is. We have to convert. The ratio... So to convert units, we have to know the ratio between our units. So the ratio between millimeters of mercury is a 760 mmHgs is equal to 101.325 kilopascals. So this is a given ratio. We know this. We need to use it to convert. So if I want to convert 650 millimeters of mercury, I need to multiply it by this ratio. In the end, I want to end up with my units in kilopascals. So this means that I need to multiply so that millimeters of mercury get canceled out. So I'm just going to write this over 1 to make this into a fraction. And then I'm going to multiply it by my ratio, which we also write as a fraction. So if millimeters of mercury are going to cancel, that means they have to be in the denominator and kilopascals in the numerator, so that I end up with kilopascals at the end. So millimeters of mercury cancel. 101.325 kilopascals is equivalent to 760 millimeters of mercury. So we multiply 650 times 101.325, divide by 760, and we end up with 86.6595 ... We don't want to round this yet because we're still going to use that number in our calculation. So now I can sub everything in. So P1 is 110 kilopascals, V1 5 liters, P2 I just found is 86.6595. I know that pressure is inversely proportional to volume. So that means if pressure goes up, volume goes down. So in this case, my initial pressure was higher than my final pressure. So I should expect my answer to give me a volume that is greater. Since they're inversely proportional, my pressure is lower, so my volume should be higher. So 110 times 5 divide by 86.6595 gives me a final volume of 6.34667 liters, which makes sense. I expected my volume to go up. So this looks like it could be a reasonable answer. How many significant digits do we want? Look back at the question. This is only 2, so my answer should be 2. So I would round to 6.3 liters.